So I'm going to start recording the video for today's presentation. If you have any problems, please you can close. I'm going to close all the videos over here. So I'm not recording any of you in this presentation. Thank you. Let me share first my screen. Sorry about this one. Okay, so let's think about the following. First off, how many of us work or study in a learning setting where a diverse range of cultures and are represented? Raise your hand or show your emoji. Okay, thank you. How many of us are fluent in a language other than English? All right, thank you very much. How many of us have experienced learning centers at university or in high school? Yeah. So just talking a little bit about centers, I was looking for information about centers and some research related to it. And I found out that most of the learning centers are based on elementary schools or kindergarten is when it's more used. So finding centers in the high school classroom or even university is quite unknown. Okay, I'm happy to be here today to discuss a topic that is very close to my heart, fostering tolerance and understanding within the vibrant tapestry of the multicultural environment. In my presentation, we'll delve into the innovative approach we use in our K-12 international school in Tokyo, Japan, to help our diverse high school students connect with science education. I will share insights on how we use project-based instruction and interactive centers with a focus on how teachers facilitate this unique learning experience. So for me, in order to create the learning centers, I examine the science curriculum and that is aligned to our students' specific needs, expectations, and desired outcomes. My objective is to deliver instruction that was not only authentic, but also personalized, tailored to the rich diversity of our students' population. Allow me to provide you with a glimpse of the unique environment. Our school, situated in Tokyo, welcomes students from various backgrounds, including foreign nationals, local residents, and those with mixed heritage, having one Japanese parent and another from a different country. Our bilingual school, both Japanese and English, serve as the language of instruction, reflecting our commitment to nurturing language proficiency and the cultural understanding. Our high school community is a testament of the diversity, comprising by 54% fully bilingual students, proficiency in Japanese and in English, 20% of whom are multilingual, speaking more than 3 languages, and 42% whose mother tongue is Japanese. It is within this multicultural mosaic that our exploration of promoting tolerance and understanding through tailored science education took shape. At our school, the focus is not primarily on grades, but it is on the rich experiences students gain within the classroom. We use continuous assessments approach using a diverse range of formative assessments tools that extend beyond the traditional written tests. Throughout the term, students showcase their knowledge, understanding of science through various means. In my class, for example, students receive comprehensive feedback on their work, both written and verbal, and actively engage in reflective practices, integral aspect of our school's philosophy. I will present a specific science class here as a model to demonstrate the effectiveness of centers and project-based instruction. To begin this journey, sorry, I'm a bit nervous. To begin here, I always give them a pre-assessment, which is very important for us. This assessment serves as a vital tool to uncover students' prior knowledge, their misconceptions, but also ignites their curiosity for them to read the questions that are coming on the exam on this pre-assessment, and thinking about the things they don't know and how that one applies to the things they already know. It's very important. The pre-assessment questions were thoughtfully crafted, some centered around the upcoming projects that I intended to assign. Throughout these assessments, I gained a valuable insight into my students' individual needs and backgrounds. It became evident that some students had a broader understanding of neuronal pathways based on their previous experiences in the previous schools in different countries. However, they encountered challenges related to vocabulary, especially in English or Japanese. The pre-assessment is written in both languages, and students who are strong at Japanese, they answer, because our objective wasn't checking on their language proficiency, it was checking on their understanding of the subject. So some students decided to write the pre-assessment in English, or they decided to answer the pre-assessment, take the pre-assessment in Japanese. So this is a sample of the pre-assessment questions. If you can see, it goes from the very basic one, labeling, into the most complex questions as analyzing data and checking how much information they can get from the data given. So it gives them the opportunity also to write their own questions. For example, the most important question in this sample at the pre-assessment was this question, which was the last one, where I asked the students to select 2 or 3 questions that they found interesting or puzzling, or perhaps questions that they were like, no, these questions I already knew because I came from this and that school, or they also had the opportunity to write their own questions. So as this student wrote over there, question 9, it was something that they want to know about the chemistry of the brain, or question 14 was even more important when they say, I already seen something like this in my previous school. So that is quite valuable for me because it served as a guiding light, because it shaped the development of the centers. These centers were 5 in total, and they were meticulously designed with information for the students. But before doing that one, I would like to share what type of projects I designed for them. So these are just sample project questions that I have for them. This group specifically is a group of 18 students from, 18 students, and I devised 9 different projects. Why 9? Because some students decide to work in pairs, some of them individually, some of them in teams of 3. So I don't allow to have more than 3 students in a team. But also students are free to come up with their own ideas, with their own projects, and they can actually suggest some of them, and they have to discuss it with me. For example, there were a group of students, they wanted to do a research, and they wanted to test some how neurotransmitters work in certain way, in certain aspects of the students' lives. That was a bit challenging, so we needed to find out the ways they could test and they could collect reliable information, and the number of students they will test, so how they will run the experiments and everything. So that had to be, that project could go after we have this honest conversation, when we had to put on the table the pros and the cons, and also the ethical concerns too. So it's this designing and their own project, which is good because they get to see how scientists work. So if you see the projects are authentic, and there are assessments too. For example, it's not about writing presentations or posters. It's about, for example, developing an interactive infographic, or a video, making a video animation, or doing creating their own podcasts about brain and behavior, or the ones doing a research about the drug effects into the neurotransmitters. So that was also really important for me and for the students. So let me outline the structure of the centers. So the centers in my classroom, if you can see, they're focused for independent work, offering students the space and to immerse themselves into projects once they have acquired the necessary skills and knowledge. So if you see the centers, we have neuron cells, structure and functions, we have the neuronal membrane action potential, the chemical brain, neurotransmitters, and one that says independent. Within this independent work setting, students enjoy the newfound freedom, the freedom to choose their collaborators, the freedom to express their understanding of the in their preferred manner, the freedom to manage their own time. So they can, in general, they can take as much time as they need to interact with the material and to actually understand what is the material about. So there is no time limit. I mean, they have a time limit to finish the whole project. So this takes the whole term. So they have to go from center to center, acquiring the information they really, truly need. And so sometimes they interact with 2 or 3 things in the center and they go, okay, wait, I already know this one. I understand fully what I need to know and I can use this one in my project. So that's fine. They don't need to go through the whole center if they don't need it, but some of them need to go the step by step process of the center so they can get as much information as they need to make sure that they understood what was the objective of it and use it in their own research. So in these centers, collaboration is very important. As the students engage with one another, they provide mutual support in deciphering the diverse activities and videos. It was heartening to hear students conversing in their native languages, striving to comprehend the content presented in each center. The atmosphere buzzed with enthusiasm and encouragement as students were not only permitted but encouraged to seek clarification from their teachers regarding specific key terms, whether in English or Japanese. The true beauty of this collaborative learning experience emerged as students engage in the peer-to-peer teaching, as they paraphrase information and explain concepts to their peers. The critical thinking skills were sharpened, and the problem-solving abilities were enhanced. This interactive exchange not only deepened their understanding, but also empowered them, fostering a sense of self-reliance that is invaluable in their learning journey. As you can see here, the students are brainstorming about a concept, SIPA, and then they are a project, about SIPA, and they're putting their ideas together and they're trying to link concept by concept of the things they learned in the center and how that relates to their project. They're discussing, as you can see there, they're writing the key terms or some words in English, in Japanese, and also mainly in English. Other students engage in something that is more hands-on and to understand the structure and function of neuronal cells. As I highlighted before, this is a sample of one of the centers that is talking about action potential. And if you can see, the center is giving them certain information to consider, but also instructions on how to interact. So center is here, in this case, is manipulative. The kids have sodium ions and potassium ions, also chlorine ions and a protein that is negatively charged. So they interact and to see how the ions move from the intracellular part of the cell to the extracellular part of the cell. I'm so sorry, this is very technical, but it's the way the students are interacting with the material and the information. They have also videos and simulators, so they have QR codes where they can access the videos and simulators. Now, we try to develop their science literacy skills. So in terms of videos, it's not about watching a video and write down every single thing that is happening on the video, but watching the video and extract the most important information out of the video, the information that is valuable for the project, the information that actually makes a big impact on understanding how the neurotransmitters work or how the neurons work. So this is just to summarize. The centers are personalized, small grouping, and it's continuously monitored by us, the teachers. We go around the centers and we try to support all of them at the same time. We also use a lot of technology, which is important. So, as previously highlighted, student reflections hold an immense significance in my instructional approach. I actively promote this practice, encouraging my students to engage in their reflections on a weekly basis, or as often as they find feasible. To enhance this process, I initiate interactions with their reflections through thought-provoking, inquiry-based questions. This method has proven to be the most valuable formative assessment tool integrated to all my science lessons. So this process is not just a student's reflection about the class, but it has a dual purpose. It provides me also with insight about their learning experiences, whether the activities or the concepts they were working with worked or it didn't work. So I gain a profound understanding of the things that goes on in the classroom from the student's point of view. This reciprocal exchange underscores the dynamic nature of learning. It's not only one-way street. Instead, it's an honest input from this is an honest input from my students to me and from me to my students. It informs my teaching practices. It fosters a continuous cycle of growth and improvement. So as you can see here, this is a sample of their reflections. So the green part is just my expectations and outcomes, what I expect the kids to do with information gained. And they write the reflections. For example, they added their snapshot of their notes. And if you can read here, this is my input. This is my comment of their notes. And at the end, I wrote a question that I expect them to answer. The reply is a formative assessment for me. The reply and their reflections is a formative assessment that is really rich of their input for me. As you can see here, for example, this student is talking about, it's the same student, so it's talking about the things they learn, but also the things they found difficult and how they approached that challenge. Sorry, how they overcame this challenge. And here, this another sample is the same, but you can see also the use of the Japanese notes with an English reflection. So the student is using both languages, English and Japanese, interchangeably. And the last one is, this is a student week by week, what are the attitudes for learning? How did they interact with the material? What did they do? Did they collaborate with others? Did they talk to others? Did they ask questions? Did they find some challenges, or were they absent? What will they do next time if they were absent in the class? So all that one is part of their reflection. Oh, sorry, I was just going very fast into this presentation. But to be honest with you, incorporating this project-based learning within the learning centers to promote global tolerance and understanding holds a significant importance in my educational approach. Creating an environment where students have the freedom to communicate in a language that are most comfortable with proved to be essential for the success of my class. I firmly believe in the power of translanguaging in the classroom, encouraging students to seamlessly blend languages. I have a group of students from the same country and allowing them to collaborate on the project, sharing their insights on their native language, while also working in the second and third language, proved to be invaluable. One of the project requirements was to present their information in both English and Japanese. This multilingual collaboration not only enhances their language proficiency, but also deepens their understanding of diverse cultures and communities. It illuminated a broader spectrum of how we learned and demonstrate the potential for improving our language skills while fostering a genuine appreciation for other cultures and societies. This aligns seamlessly with the core objective of a globalized education. If you have any questions, please feel free to ask them. I'm gonna stop sharing the screen. And let's go and we have very few minutes to share any questions or concerns that you might have.